Did you know that cholesterol is not only a building block of your diet, but also plays a key role in the health of your brain? This is especially true for diseases like multiple sclerosis, where the destruction of myelin, the protective sheath around our nerve fibers, leads to significant neurological problems. Cholesterol is not only central to the structure of myelin, but also crucial for the regulation of lipid metabolism, which plays an essential role in myelin repair. Why is cholesterol so important for myelin? And what is myelin anyway? Myelin is a protective layer that surrounds the nerve fibers in the nervous system. You can think of myelin like the insulation around an electrical cable. This insulation ensures that electrical signals are transmitted quickly and efficiently from one nerve to another. Without myelin, the signals would travel more slowly, which would impair communication between nerve cells. Cholesterol, in turn, plays a crucial role in the structure of myelin. It is one of the main components of this insulating layer. Interestingly, cholesterol is produced almost exclusively on-site in the brain, primarily by specialized cells called oligodendrocytes. These cells are responsible for producing and maintaining myelin. Especially during brain development and in early life stages, it is important that sufficient cholesterol is available. An adequate supply of cholesterol is essential for forming stable and functional myelin layers. If these layers are not formed correctly, it can lead to problems in signal transmission in the nervous system, negatively affecting overall brain function. Therefore, cholesterol is not just a simple lipid but a vital building block for the health and function of the nervous system. The study we are focusing on today is the review article Local Cholesterol Metabolism Orchestrates Remyelination by Stefan Berghoff, Lena Spieth, and Gesine Sayer. This work summarizes the current findings on cholesterol metabolism during remyelination. A review article is a scientific publication that systematically compiles and analyzes existing literature on a specific topic to enable new insights or a deeper understanding. In this case, the review provides a comprehensive overview of the role of cholesterol in remyelination, particularly in the context of multiple sclerosis. The research examines cholesterol uptake, recycling, and de novo synthesis in various cell types of the central nervous system during acute and chronic phases of demyelination. A particular focus is on liver X receptors, which regulate lipid metabolism. These receptors promote anti-inflammatory processes and improve cholesterol recycling, which is crucial for myelin repair. What role do microglia and macrophages play here? These specialized immune cells in the central nervous system are important for defending against diseases and for the balance and stability of nerve tissue. They help break down myelin debris and reuse the released cholesterol. In acute demyelination phases, meaning times when the myelin sheath is temporarily damaged, this process works well. The immune cells collaborate effectively, supported by mechanisms that regulate fat metabolism and reduce inflammation. In chronic demyelination, however, recycling becomes less effective. This means that the immune cells can no longer work as well, leading oligodendrocytes, which are responsible for the formation and maintenance of the myelin sheath, to produce more cholesterol themselves. Neurons are also involved in this process, highlighting the need for increased cholesterol de novo synthesis. The researchers found that phagocytes take up cholesterol from degenerated myelin during acute damage, which inhibits cholesterol synthesis in these cells. However, in chronic stages, regeneration is limited by the availability of cholesterol, emphasizing the importance of local synthesis. What are the strengths and weaknesses of the study? The study is characterized by its detailed analysis of the cellular processes that occur during acute and chronic demyelination. Particularly valuable is the finding that liver X receptor agonists could promote cholesterol regulation and thus myelin repair. However, there are also limitations. The use of animal models raises the question of how transferable the results are to humans. Additionally, potential conflicts of interest, such as the author's patent application for the therapeutic use of squalene, a cholesterol precursor, could influence the interpretation of the results. What are the practical applications of this research? The findings of the study could pave the way for innovative therapies that specifically modulate cholesterol metabolism. Liver X receptor agonists could enhance anti-inflammatory effects while simultaneously promoting myelin regeneration. Ketogenic diets, which support the production of cholesterol precursors, could also play a role, although their long-term effects still need further investigation. Now let us summarize and look ahead. The study clearly shows that cholesterol plays a key role in the formation and repair of myelin. Future research should aim to develop therapies that have anti-inflammatory effects and promote myelin regeneration. Particularly promising in this regard are liver X receptor agonists, which could activate specific signaling pathways and support myelin repair. Ketogenic diets could also contribute to the repair of nerve damage by positively influencing cholesterol metabolism. However, caution is warranted. This dietary approach is not suitable for everyone, and its long-term effects have not yet been fully researched. Therefore, it is important to consider individual differences and needs. If you enjoyed this video, please give us a thumbs up and let us know in the comments what you think about the role of cholesterol in brain health. What significance do you believe cholesterol could have in other areas of medicine or in ketogenic diets? We look forward to your thoughts and suggestions. Don't forget that the links to the studies mentioned can be found in the video description. And as always, we wish you a long, healthy, and happy life until next time.